पहिली slide देना. It's a presentation on topic laser and its applications. Contents of this presentation you can see. Those are introduction of laser, principle, kinds of laser, then construction and working of two types of lasers we will be discussing, then applications of laser in different fields we will be talking about. To begin with introduction, you can see the laser word LASER. It stands for light amplification by stimulated emission of radiation. Essentially, lasers are highly intense, highly directional, highly monochromatic, and highly coherent optical sources. And the basic concept of laser started from stimulated emission, which was postulated by Einstein in 1917. In 1960, a solid state ruby laser was developed, whereas in 1961, a gas state laser, helium neon laser, is developed by Bell Laboratories. The principle of laser includes the basic interaction happening between the matter and radiation. You can see the interactions are mentioned: absorption, spontaneous emission, and stimulated emission. The first one is absorption. So it's the process of exciting the atom to higher energy level by absorbing the photon which is incident on the atom. This is called induced or stimulated absorption of radiation. When atom goes to excited state, lifetime of atom in excited state is very less. It is of the order of 10 to the power minus 8 seconds. So when lifetime is over, atom has to leave excited state. In that process, when atom leaves higher energy level to come to ground state, it radiates a photon of energy h nu, which is random in character. The second probability of de-excitation of atom, it is consisting of stimulated emission wherein the photon is incident on the atom in excited energy level so that the atom de-excites, and in the process it gives out two photons having same frequency, same phase, same direction of propagation and same plane of polarization as that of incident photon. These are different kinds of lasers: solid state, gas, liquid laser, dye laser, semiconductor laser. And in front, the examples or the actual lasers are mentioned, like ruby laser, CO2 laser, and so on. This is the diagram which is showing the components of first ruby laser, and it indicates the construction of ruby laser, wherein the red color beam is a laser beam, and basically a rod of ruby is used for this. In the diagram you can see the details. Optical resonator cavity is achieved by 100% reflective mirror and 95% reflective mirror. Talking about construction of ruby laser, it uses a cylindrical rod of ruby which is made up of aluminum oxide, and it is doped with 0.5% weight of chromium oxide. One end of rod is fully silvered and the other end is partially silvered, so that the rod acts as optical resonator. The rod is surrounded by a glass tube which in turn is surrounded by the helical flash lamp filled with xenon gas, so it is called a xenon flash tube. In the working of ruby laser, you can see the energy level diagram is drawn. When the flash lamp is flashed on, ruby rod uh, and the chromium ions are excited to higher energy states. After staying there for 10 to the power minus 8 second, ions get transmitted to the metastable state, and the laser radiation of wavelength 6943 Armstrong, which is bright red in color, it is given out. This is a pulsed wave laser wherein the output beam ceases when the excited chromium ions are over. This is about construction and working of helium neon gas laser. It is consisting of a discharge tube having fully reflecting face on one side and partially reflecting face on another side. The mixture of helium and neon atoms is filled in the discharge tube in proportion of 10 is to 1, and across the cathode and anode of this discharge tube a very high potential difference is applied by radio frequency generator. So you can see the highlights of construction. The laser is consisting of a large and narrow discharge tube that is maybe 1 centimeter in diameter and around 50 centimeter in length. It is filled with the atoms of helium and neon gases in proportion of 10 is to 1. The tube is enclosed between fully and partially reflective mirrors which serve as optical cavity, and the two windows are set at Brewster's angles so reflected radiations enter into the tube and become polarized. This is the energy level diagram to explain the working of helium neon gas laser. You can see there are different energy levels to indicate the transitions of helium and neon atoms. Helium atoms, after transferring their energy to neon atoms, are excited to 2s and 3s. The population in these levels is more than those in lower levels. That means population inversion is achieved here, and the emission of radiation having wavelength 6328 Armstrong is reached. It gives continuous emission of radiation, that means it works in a CW mode. These are few applications of lasers. Lasers are used in communication system. So in optical fiber communication, laser bandwidth is very high compared to the radio and microwave communications. Due to this large bandwidth, more amount of data can be sent, more channels can be simultaneously transmitted, and lasers are also used in other communication systems. In industry also, lasers have many applications, like lasers are used to blast holes in diamonds and hard steels. Lasers can cut, drill, weld or remove metal from surfaces and perform these operations even at surfaces inaccessible by mechanical methods. Lasers rangefinder is used to measure the distance to making maps by surveyors. Argon and carbon dioxide lasers are used in treatment of liver and lungs. New kind of laser surgery that uses molecules to stitch together the wounds, that is also done by using laser. Then CO2 laser is particularly used in spinal and brain tumor excision and kidney stone extrusion. Then lasers are used in the treatment of glaucoma. Lasers are used in the eye treatment, as in to repair a detached retina. It's a kind of disease wherein the broken loose from the rear part of the eyeball. It is attached by using laser. Then laser is very useful in removing extraneous blood vessels that can come on the retina. A thin light sensitive membrane at the back of the eyeball, that is retina of course, and this is the way that surgery works. It is shown in the diagram over here. Lasers are also used in military. You can see as a laser beam can be bounced off a target such as enemy airplane or ship. Lasers are used to determine its distance and speed. Again, lasers can serve as war weapon. It can even be used as high energy lasers which are employed to destroy enemy aircrafts and missiles. Advantages of using lasers are mentioned as follows. You can see, just to cut glass and drills holes in ceramics, lasers are used. Lasers are used for bloodless surgery and in destroying kidney stones and gallstones. Lasers are used to study the internal structure of microorganisms and cells. These are also used in air pollution to estimate the size of dust particles. And these are few disadvantages of laser mentioned here. These are known to be dangerous to the atmosphere and health. laser printers are very costly while compared to other printers. When running the laser machine, small amount of ozone are generated which can damage the ozone layer. Some laser particles are also known to emit particles that may cause respiratory diseases. And the final conclusion of this presentation is that the role of laser is crucial role in modern world. Therefore, lasers play an important role in the present technological world.